All right, guys. So here we are. So we had just started talking about, basically how the loan installments or the amortized loans work. The formulas that we are using in this section are the present value formula, so the PV, and the payment formula, the PMT, and those are the built-in formulas that we have in, your spreadsheets. And then these are the loan formulas that your textbook has, right? So these are the, depending on, are you calculating the principal, the amount of loan that you will have, or are you calculating what your loan payment, and that can be in terms of, whatever frequency you're paying the loan payments at, right? Oh, okay, Sabrina, no worries. Okay, so we had just started looking at some basic examples of, how we can work with, based on, we had looked at the example here where basically if you knew what you could afford paying each month, then basically what would your lump sum loan amount would be. So that was that first example where we said, if you can afford paying $200 a month, then what value of car you can buy, or, how much loan you'd be able to take out. And then the second example we had looked at was the mortgage, home mortgage. How much would you end up paying? And this was kind of an interesting example because you're starting out with $140,000 mortgage loan. You're paying a 6% interest, and of course the loan is for 30 years. So by the time we calculated what our monthly payments would be, which came out to be the $839.37. And you can see how they use the payment formula for that. So you can use, of course, that built-in function, or you can use this formula to figure out what those monthly payments are going to be. Yeah, Sabrina, we can take a look at those questions for sure. So based on that, then, again, you would come out with the same $839.37, monthly payments. Now you are making these payments over a 30-year period. And of course, since you're paying monthly, you multiply this with 30 and 12, and you can see you end up paying, by the end you have hit 30 years, $302,000, and a little over that. And your mortgage loan was only $440. So you can see you are paying a big chunk of that money just in interest, right? I mean, more than the value of the home you came up with. So that's kind of, some of the things we wanted to look at. So let's pick a couple examples here from, keep doing the same thing, from your 2.4 section. So we did example 2 last time. So something similar to that mortgage payment. Let's take a look at, let's look at number 6. That one looks good. Oh, the equation for the loan payment, that would be this one here. So these are the two formats. Excuse me, guys. And we'll come back and revisit this here in a second, Sabrina. So number 6 is what we're looking at. So again, they're telling us Lynn bought a $300,000 house, paying 10% as the down payment, and then she's financing the rest. So 300,000 is the house payment, 10% down, financing the rest at 6.5% APR for 30 years. They're asking us to find the monthly payments. They want to know how much interest she'll basically pay over the, the life of the loan. And then of course, what is the percentage of her total payment? What was that as interest? So let's take a look at what these come out to be. So we have 300,000 as the value of the house. She's making a 10% down payment. The rest of it is going to be financed at 6.5% APR, and we're doing this for 30 years. We're trying to figure out what the monthly payments are. How much interest will she pay? And the percentage of the interest based on her total payment. Okay, so let's transfer all of this over to our spreadsheet here. And again, if you guys need a link to this spreadsheet, I'll share that through the Zoom chat again. Okay, so this guy is example number 6. So if the value of the house is $300,000 and they're telling us that she is going to pay 10% as a down payment, basically how much is she paying towards the down payment then? How are you going to calculate that 10%? Because, you know, they're telling us she's buying a $300,000 house and making a payment of 10% and financing the rest. Let me see, I have Michael. Yeah, Terry, very nice. The number times 0.1, or, you know, basically 10% converted to a decimal. So yeah, just take the value of the home, the $300,000, and multiply that with 0.1, which is what your 10% will come out to be. And Michael, that's right. You will end up with $30,000 as the down payment. Perfect. So for the down payment, and again, you know, you can use your calculator, or you can let Excel or Google Sheets do the math for you. So basically take, you know, a cell put equal to in there. I'll take the value of the home and multiply it by 0.1. And that tells you, you know, what the down payment will be. So that means the loan amount, which remember can also be the principal, since that's how much money she's going to be borrowing, will be the value of the house. And since she's paying $30,000 upfront, you know, obviously she's not going to be financing the full $300,000. So you can see the amount that she's going to borrow from the banking agency, you know, wherever she goes, will be $270,000, right? After you take that 10% out. Okay, so that's the beginning part, which basically they said that in the first sentence. Then they are telling us we're going to be looking at an interest rate of 6.5%. And again, I actually want to format that to a percent first. So format that, and then I'll type in my 6.5%. The period for the loan is, of course, going to be 30 years. And then they said, what were her monthly payments going to be? So yeah, end value will be 12 for the monthly. So again, you know, the first part is they are asking us to find what the monthly payments are going to be. So let's come back over here. If you are finding the monthly payments, you can either use the PMT formula, the spreadsheet formula, or from the textbook formula, this is the one you are going to be using. And I already have this formula, I believed, copied over here. No, that was the present value. Okay. So let's copy that over then. So if you're finding the monthly payment, you can use the PMT formula, which will basically help you find, the D value. Or you can use the textbook formula over here. So for the PMT, I mean, again, all of these formulas are kind of set up very similarly. So you start by your rate per period. So that's, of course, going to be the R divided by N. For the second argument, we do number of periods. So this will, of course, be your N times T. Your present value, which, of course, then comes out to be, the amount of loan you are taking or your principal. And in this case, it's not really going to be amount deposited. Remember, this is going to be the amount of loan you are taking out. And you can kind of see that over here in the description with the loan formulas where they're telling you the P value is the principal or the loan amount. So that's kind of what you are looking at. So that's the present value. And then, of course, for the last one is going to be the future value. Now, remember, again, I had mentioned this last time, because we're talking about loan in the future value, when you pay off your loan, your balance comes out to be zero, right? Because you don't want to have anything left over. So in this case, your future value will be zero. So just kind of keep that in mind, from when you saw this formula in section 2.3 and how it's being used in section 2.4. So that's kind of how you're going to do the built-in function. And then, of course, you can see for the textbook formula over here, you are again using the principal, which is again, how much loan did you take out, R, N, and T. So we already have all of that information in our example to begin with. So let's go ahead and plug these numbers in. So we'll start out with our built-in function, the PMT formula first, and then we'll come back and do the textbook formula. So over here, we'll start with equal to payment PMT. And then remember, your first argument is going to be R divided by N, comma. Then we do N times T. So that would be N times T for the second argument. Then the third argument is your present value or your loan amount. So that will be the $270,000. And then, of course, our future value is going to be 0. And since I didn't create a space for it for now, I'm just going to type in a 0 over there. So that's how you're plugging in your values, your arguments in there. And you'll see as soon as you hit enter, it will tell you what your monthly payments are going to be. So this is going to be the part A of your Sabrina, how did you type your arguments in? Because you really shouldn't be getting an error message. You're taking your R divided by N, so that's the 6.5%, or as a decimal, remember 6.5% will of course become 0.065, and then you're dividing that by 12 in the first argument. The second one, you are doing N times T, so that would of course in this case be 12 times 30. Then the next argument is your present value, so the $270,000, and then 0 at the end. And I'm looking at your image here. So what do you have? P equals 0. So P is not the value that's going to be equal to 0. P, of course, is going to be the $270,000. And then it's your future value, the loan amount, which technically we call that as A. Because if you're using P for both the loan amount and then you're using P as 0 at the top again, you're going to get confused. So the one where you have the 0, I would call that as an A because that's your future value. But either way, you've got, B64. So 0.065, is that in 64? Yeah, divided by the N, which is 12, okay. B65 times B66. Sabrina, you don't have, after the equal to sign, you don't have PMT, you just put equal to, and then parentheses. So as soon as after the equal to, you put PMT, because you haven't given which function you want to use, right? You just said equal to and then did the parentheses. So as soon as you replace that, you'll have, yeah. And then remember how these functions always give you a negative answer, just the way they are designed, but we know it's a positive number because that's how much we'll be paying. So I'm just going to type that number right next to it and make it a positive number. So 1706.58. So you can see we are making monthly payments of about $1,700, right? Now, let's take a look at how we can type this in using the textbook formula. So again, we'll start out with the equal to. Now you're taking your principal amount. So that's the $270,000, multiply it. And then again, in parentheses, like you have it in the numerator, we'll type in R divided by N, close parentheses. So this takes care of your numerator. Then we have division, and kind of type in the same way as you see this. So you'll start out with your open parentheses first. So we'll do open parentheses, then you have the 1 minus after that, 1 minus parentheses again, and that'll represent this second one. And then we're going to be typing in 1 plus R divided by N. So 1 plus R, which is the 6.5%, divided by N, that's 12. Close parentheses. So this is closing up our, first set over here. And then you will see, guys, we have a negative N times T. So we have a negative exponent there. So after we get, our close parentheses at this point, you'll use the caret symbol. And then in parentheses, we're going to do negative N times T. So N times T. Just make sure you have that negative sign in there. And as I was explaining to you guys last time, because we have, the amount decreasing, because every time you make a payment, your amount decreases, and that's what that negative exponent basically does, is helps you decrease your balance as time goes by. And then the last thing we're going to do is close this parentheses again so that we can, put the whole denominator in one set of parentheses. So that's what you're going to do after you type the negative N times T. Close the parentheses one more time. And you should obviously get the same dollar amount as we did from the PMT formula. So I'll leave this here so you can kind of see how I typed that in. So this was part A. What is our monthly payment going to be? Now for the part B, obviously, then they were asking us how much interest has Lynn paid over, the time of the loan. So that's part B over here. How much interest will she pay over the life of the loan? So let's take a look at that. So for her interest calculation, of course, we're going to take our D value that we just calculated, multiply that with the monthly payment. So 12 times 30 years. So D times N times T. And this guy will come out to be, let's see, I'm going to use the positive number here. So equal to our positive number times N, which is 12, times T, which is 30 years. So over the life of the loan, Lynn will have paid $614,368.80. And I'm sorry, this should not be interest. This is how much total amount has she paid. Because we still have to calculate the interest. Okay, sorry, that was the total amount paid. Now let's talk about how much interest was that. So this is where we take the D times N times T, and from that you subtract your loan amount, so the principal. And that was kind of the similar calculation we had done in example 2, as you can see on the left-hand side. So for the interest, we're going to take the $614,368 and 80 cents, and from that you will subtract how much loan we had, which was the $270,000, and you will see this is going to be the interest Lynn has paid over that 30-year period. So $344,368.80. So that's how much interest she paid on her loan. Then the last part they're asking us is, of course, to figure out what percentage of her total payment was the interest. So this is, again, going to be the interest divided by the total she paid. So this is where you will then take the $344,368, the interest that we just calculated, right? And then divided by that total payment she made of the $614,368.80. And again, remember, by default, this will always come out to be as a decimal answer, and then you can convert that into Sabrina, I'm not sure in which part you're asking that question. Is that from part A? So just take your formatting, guys, and change that percentage, the decimal, to a percentage. So as you can see, this will come out to be 56.05%. More than half of the payment that Lynn has made, right, towards this loan is basically going towards interest. And that's kind of, if you remember, we had talked about right at the beginning of this section here, with that little graph that they had, when you look at, for that first part, you are paying a big chunk of your money towards the interest, because remember, at the beginning, all of that money goes towards interest. And as time passes, the interest amount goes low and more of your payment goes towards the principal. So in the beginning, you are paying more interest in terms of the principal. And then as the time goes by, you start adding more towards the principal and less towards the interest. And, because this is an exponential growth, you will see how you end up, paying back more than double of what the amount of money you borrowed. Unfortunately, that's just kind of how the structure works, right? Because banks also have to make their own profits. So questions on this example, guys? All right, Sabrina, let me see what you have in here. Oh, putting the equation into the spreadsheet. Yeah, so this is going to look like this over here. So you start by taking your principal, because it's the payment you're finding, right? It's the D value you're trying to find. So you're actually taking your P value. Terry, just give me 1 second, okay? You're taking your P value. So after you do the equal to, you take your P value, which is that 270, you multiply it by R divided by N. So that's how you're typing in your numerator. Then you do the little division symbol after that. Oh, and I didn't pick a good spot for this. Hold on. Let's do it here. So when you're typing, you take your p-value, then multiply by r divided by n, close that. So this is your numerator. Then you hit division, open parentheses, 1 minus, open parentheses again, 1 plus r divided by n, close parentheses, then raise it to the exponent, parentheses again, minus n times t, close this parentheses, and this one you're doing for the exponent, but then you do one more parenthesis so that you're closing this guy over here. So to close this guy, you basically end up with another set of parentheses. So you should have 2 of them in the back. Terry, go ahead.
Can you please write out the formula under interest and total paid percentage?
Oh, okay. Hold on. Let me get rid of this guy. So this one actually is just, so if you call this guy as your interest, so this then actually comes out to be, as a formula, would be your I value divided by your D times N times T value. Okay, okay. Sabrina, yeah. So, Sabrina, I'm looking at your message in the chat, and it actually looks like the formula you typed in there was actually when you're trying to find the present value of your loan, because when you are doing the payment, you will see how different these two formulas are. I mean, they're the same formula, they've just been rewritten. So when you're trying to figure out what the present value, or how much loan you can take out, that's when you use this version. But in this example 6, we're actually calculating what our monthly payments would be, right? So we're actually using this modified formula here. Okay, that's fine. Alrighty, guys. So this was our example 6 on trying to figure out if you are taking out a loan, making a down payment, how much loan amount you basically take out. So obviously we didn't go for the full $300,000 since we did the 10% down payment. So we were only taking the loan amount for $270,000. So then based on that, what were our monthly payments? How much money did we pay in total? Based on that, then we calculated what the interest was. And then of course, what percentage of our total payment did the interest come out to be. So that's basically what you did here in question 6. Now let's take a look at just a slightly different example here. Let me clear this out. There we go. All righty. So this was on a home mortgage. Oh, that one is kind of similar to that. Okay, let's look at number 8. This one is a little bit different here. So number 8 is talking about a friend bought a house 15 years ago, taking out a $120,000 mortgage at 6% APR for 30 years. And they basically want to know how much does she still owe on the mortgage. So the loan was taken out 15 years ago for a $120,000 amount, 6% APR for 30 years. And it's of course been 15 years. Okay, I think that's all the information there, right? Okay, Sabrina, no problem. Alrighty, guys, so let's take a look at number 8 over here. Okay, so of course, since the mortgage amount was 120,000, that's our principal. So 120, gonna format that as dollars. The rate is 6%. Again, I'm actually gonna format the percentage first and then type in my 6%. The loan itself is for 30 years. Normally these payments are made once a month, so we're just going to use our end value as monthly. And so now it's been 15 years since they took out the loan. Sabrina, that is correct. Yeah, very nice. All right, very good. Okay, so since they're telling us that the loan was taken out 15 years ago and it's a 30-year mortgage, how much do they still owe on the house? Let me see what you guys are thinking. Like, how do we go about calculating this? So again, if you want to see the question, that's question number 8 over here. So a friend bought a house 15 years ago, taking out a $120,000 mortgage at 6% APR for 30 years. How much do they still owe towards this house? So first we need to calculate, right? Like what they're going to be paying over a 30-year period. That was your monthly payment, Sabrina. Okay, Michael, so you are saying do the formula after 30 years, then do it again after 15 years, and then subtract the 2, is basically what you're saying. And then Amanda, you came up with 117,727. You want to tell me like what you did there to get that number?
I used the formula as in sheets, and it said the total amount paid, and then I subtracted that from the value of the house.
Oh, from the value of the house. Okay.
Rather than the loan.
Okay.
The payment total was over the loan amount as far as what I got
Okay.
for 15 years.
Okay, so you did it for 15 years for now?
Yes.
Okay.
As in, so I calculated like the payment and then I multiplied it for 15 years.
And you multiplied it for 15 years.
Oh,
Okay.
wait. Hold on.
Alrighty, so Michael, I kind
Alrighty.
of like where you were going with this. Yeah, go ahead, Amanda.
I don't know why the total amount paid is showing a slightly different amount than what, like I multiplied it by hand on the calculator and got 182,340, and my total amount paid on sheets is showing 273, and it's like slightly off. Is that even?
Okay, so let's take a look at, because I haven't done the math yet, so I'm not sure what the number should come out to be. So let's start out with the original loan, right? So you have the $120,000 at 6% for 30 years, and we're making monthly payments, right? So let's first figure out what our monthly payments are going to be. So of course, since you're figuring out the monthly payments, you do want to use the PMT formula, and that will give us our D value. So remember, again, for the PMT formula, we start by equal to PMT, and then in parentheses, you're going to do R divided by N. So 6% divided by our 12 months. For the second argument, of course, we do N times T. So that would be N times T. Then argument 3 over here, remember, is your principal, the loan amount that you got out. So that would be the 120,000. And then your future value, of course, is going to be 0, right? Because we want to pay off the loan. So just like you did before. So this is what your monthly payments for 30-year period should come out to be. And, of course, we know that's always going to stay the same till the end of the loan period. So that will be your monthly payment over 30 years. You put 15 instead of 30. That's kind of what I was thinking, Amanda. Yeah. Because that's why you were getting a larger amount also. So you are looking at $719.46. And then, of course, let's see what that looks like for, oh, where's my cursor? Okay, so the second step, Michael, you mentioned was then you repeat the calculation for 15 years, right? But this is what's going to happen. If you repeat the calculation only for 15 years, it's actually going to increase your payment amount significantly, right? Because now instead of taking a 30-year loan, you've only taken a 15-year loan. So that monthly payments will go up really high. So you don't really want to do the same calculation again over a 15-year period, because that will come out to be very large. No, you're not subtracting in half also. Give me a second here. I just want to show you again, if you are using the textbook formula, guys, how you would find your payment in this example. So just to show you the math for this, again, we'll do equal to, then you take your present value of the 120,000, multiply it by R, that should be in parentheses. So multiply it by R divided by N, and that takes care of your numerator. Then we do division, open parentheses, 1 minus, then the second parentheses. In this one, you are going to put 1 plus R divided by N. Then you close your parentheses. Then we are raising it to that negative exponent of NT. So then we do the little caret symbol. In parentheses, again, you're going to do negative N times T. We're closing the exponent, right? Just N times T. And now you're closing the whole denominator. So you should have a second parentheses closing at the end. And, of course, if you guys can see, and I'm just giving you guys to look at the formula for a second here. You can see over here, it's showing you are still going to get that $719.46. So it will give you the same dollar amount. So that's what your formula will look like. Okay, so now that we know how many monthly payments we are making, what you basically want to do at this point is figure out what the present value of your loan is going to be at this 15-year mark, because you've made the payments for half the time of the loan, but now you're trying to figure out, okay, so I still have 15 years remaining. So I have all of these payments remaining. So how much do I still owe? So you're basically now actually going to go back and either use the present value formula or use this P equals formula for your textbook, but you're only going to be doing this for 15 years because you've already paid, for 15 years going forward. So this is the first part. So now for the second part, so I guess I'll call it after 15 years, what happens? So now you're going to be using the present value formula. So remember, this is going to be PV. And again, you kind of start out the same way. And just to show you over here for the present value formula, you're again doing rate per period. So R divided by N. For the number per periods, it's going to be N times T. Now, this is where you're going to put that payment amount, which is what we just calculated, the $719. And then, of course, our future value, of course, is still going to be zero because you're still going to be paying off your loan. So that's what this will come out to be for the present value. So let's go back here. So start out with your R divided by N. So the 6% divided by N. Obviously, we're still making monthly payments. Now you are going to be doing the N times T in this case. And this is where we need to do the monthly times and this is kind of where I'm actually going to put my 15 years. I'm going to stop that for a second. So let's do this as 15 years where you have paid your loan. So that's going to be your N times T. So this is the 15 years. That's where it's coming in. And then, of course, our loan amount of the $719.46. And remember, your future value is still going to be zero. So this is telling you basically how much of a payment you have made and how much is remaining. Because, it's at 15 years, right? You've paid the first 15 years and you've got 15 years left over. So again, you can change that into your positive number, $85,258,054. So this was using the payment, the present value formula. But again, if you wanted to use this guy, then this is the one where you will have equal to our D value was the 719.46. Multiply that by, and then since all of that is in the numerator, you'll have open parentheses, 1 minus, open parentheses again, 1 plus, and as you can see in the formula, R divided by N. So your R is 6%. N is monthly, so that's the 12, close parentheses, and then again you have the negative exponent, so caret, inside parentheses, negative N, so that's the 12 times T. Now again, remember guys, this is the time as 15 years, so N times T will be 12 times 15, so that takes care of the exponent. Now you will close your parentheses again because we want to close that whole, the 1 minus 1 plus thing. So close your parentheses again. And then in the denominator, you're going to have your R divided by N. And of course, you want to put that in parentheses also. So R would be 6% divided by N, of course, is your 12. So basically how we type this in example 2, that's the same way you're typing here. The only difference is this time you are using the 15%. So you can call this as time sub 2, or I don't know, T.1, just as a different version. So you know that's not the same as our original amount. So this is going to be how much you are going to owe after your 15 years you have made payments after your 15 years. So basically what you did was you took the original time frame, so the $120,000, the 6% APR, the loan amount of 30 years, then you're making this monthly payments, right? So those were your 4 initial amounts you started out with. Based on that, we calculated what our monthly payment is going to be. So you can use the PMT formula or the D equals formula from the textbook, and that gave us the $719.46. Once we know, okay, these are the payments we're making on a monthly basis, then you can go for how much your payment is remaining to figure out what the future value of your formula is going to be. And that is where, it's not the future, the present value. That is where we use the PV or the P equals formula from your textbook to figure out, okay, how much of my loan amount, has been paid and how much is basically left. So the $85,258.54. So this example is basically using both PMT and PV formulas. Question, guys? Okay, I'm seeing something here. Okay. The PV formula again. This one? Or from the textbook, Amanda? Okay, so remember, this is where you're using for the PV formula, since we're doing this, after you've made the 15 years of payments and you have the 15 years remaining, this is where you are using the 15 years for the T value. So I wonder if you made that change or not. Sabrina, what am I looking at in the screenshot you sent me? Yeah, we are, Michael, just here very quickly. Okay, 1 second, guys. So Sabrina, that number, when you do the D times N times T, was the 344, 368, 80. That looks good. When you subtracted, did you actually do the D times N times T calculation? Because that's where you're supposed to get like the 600, 14,000 something. And then when you take your total payment amount and subtract, yeah, so that's where your interest should come from. But where you're doing the DNT minus P, I'm not sure why that guy looks like 355, because that should be the same value as your DNT, so they should both be 344. 368.80. Amanda, were you able to fix that? Okay, so remember you're using the 6% interest, so that should be 0.06 if you're using it as a decimal. You divide that by 12, so that's going to be that first part. So once you're doing that PV formula, you're still taking your 6% interest and dividing it by n, so that should be the 6 and the 12 here. Then for the second argument, you are doing n times t, which in this case would be the 12 times the 15 years now. Then for the D29, that's actually your monthly payment. So that's the 719 you should be using. And then since our future value has to be 0, that's the last argument. You put a 0 at the end. So make sure all 4 of those arguments have the right numbers in there.
I think I'm confused about why, like how, because if I change the formula to 15 years, then it changes the payment amount.
No, you're not changing. Sorry, go ahead.
Sorry. Because I used the cell references. So when I changed it to 15, it changed the payment back to 1,000.
So you're not changing the payment here. In this calculation, we are using T as 30. So you will see that's why I have 2 different cells. One of this says 30 and then this one says 15. So that way
okay.
I would have 2 separate cells, because in the first one, you do want to keep it at 30 years. Okay, anybody else have question on this example over here, guys? Okay, Sabrina, I see your message in there. Yeah, because your interest and the D times N times T minus P, obviously it's the same calculation. So those numbers should be the same. Okay, so one thing I wanted to clarify before we move forward from this example number 8 over here, guys. So the reason why you cannot just, because Michael had kind of shared some of these ideas in the chat, was can I just take, our monthly payments, the $719.46, and you can always do the 12 times 30, right? Which will tell you how much you're going to pay over a 30 period time frame, and then divide that by 2. But remember, the reason you cannot do that, and this kind of goes back over here, because it's not halfway, right? It's not like you're making the same principal and the same interest payments every year. Remember how in the beginning you end up paying more towards the interest and less towards the principal. So that tells you that you are going to end up paying more on your you're going to end up paying more on your interest at the beginning and less on your principal. So you cannot just divide it in half, because as you can imagine, you're ending up paying more towards the principal. So that's the reason why. Okay, Amanda, I'm glad you figured that out. So that's the reason why you cannot just take your 719 multiplied by 12 multiplied by 30 and get your total amount, and then divide it by 2. What if instead of 15 years, they had said it's been 20 years and you have 10 years left, right? That wouldn't be halfway of the time frame. So that calculation wouldn't work. So just keep in mind, this is the breakdown. Start with the original value. So this was where we used 30 years as our time, found the monthly payments. Again, if you use the textbook formula, same thing, we use 30 years over here. Got our 719, and then using 719 as our deposit, but this time we changed the time in the PV formula to 15 years. Same thing over here when you are using the textbook formula also, you're doing this calculation again at 15 years. So the first two calculations were time as 30 years. And then the payment, sorry, the present value was using time as 15 years. So that's the breakdown you have to work out in this example. Guys, if you don't have any other questions on this, let's go back and finish the last half of this chapter over here. Okay. Yeah, so the 344, 368, 50, was it 50 cents? 80 cents, 344, 368.80. That's what you should have as your interest that you get from your total payment minus the loan amount. So you have 344, 368.50. So you're just shy of 30 cents there. And then the last part will be you take that interest amount and divide it by your total loan payment of the 614,368. So that's how you will get that 56.05%, Sabrina. Okay, let me just save this screen before I clear it out, so that's not in our way. So again, just to answer Sabrina's question over here, guys. Sabrina, you are taking your D times N times T. So that's going to be your 17,068.58 times 12 times 30, which gives you the the 614,368.80. Then from this 614, you will then end up subtracting the 270,000, which you've already done. So you end up subtracting the 270,000, and that's what gives you your interest payment over here of the 344, 368.80, and then divide the 344, 368.80 by that total amount of 614, 368.80, and that will give you this percentage. So that was the last part. Yeah. Yeah, so the PMT tells you what those regular payments will be that, you know, you're going to pay towards getting your loan down to a zero. So the PMT is the same thing as your D. So the PMT is also calculating the D. And then, of course, this is the textbook formula for D. But yeah, they both give you what those regular deposits are going to be. So no, your payment, as you can see in the spreadsheet over here, your payment should come out to be the same thing. So just to show you how we type this in, you know, remember for the payment, you start out with the equal to PMT, and then this is where you do the R divided by N. So that's, of course, the 6.5 divided by the 12. Then you do N times T. So that, of course, would be the 12 times 30 here. Then the next one is your loan amount. So that was the 270,000. And then our future value is always 0. So the last argument would be 0 in this case. So yeah, if you use the textbook formula or you use the PMT formula, the dollar amount should come out to be the same. So I would say just make sure your numbers are all looking okay. Yeah, no, I would say go back and check your interest, make sure it's coming out as 6.5% or 0.065. And then make sure for the principal, you are using 270,000 and not 30,000. Because since you did make the 10% down payment, you're not paying that 30,000, right? You've already paid it upfront. So your loan amount is only 270. So I don't know if that's where the error is happening. And then, like I said, your last argument is always going to be 0 because that's your principal, which should come out to be, obviously $0 when you've paid off the loan. So check that and see if that will, give you the 1706.58. All right, guys, the last part of this section is basically the example that we just did over here with the Sabrina, I'll answer that here in a minute. Yeah, just check your numbers, make sure you're using the correct numbers, but I'll come back to that in a minute, like I said. So here, guys, basically the example that we just did was what this example here is talking about is, just basically figuring out, like I said, instead of 15 years, what if they had said, it's been 20 years since they took out the loan, you still have 10 years left, what your remaining balance would be. So this is where this example kind of gets into those calculations. So same thing, you have a 30-year mortgage payment at an interest of 6%. The payment amounts $1,000 a month. What will be the loan balance in 5 years? And you will see they did the same thing. Now, in this case, because they gave us what the monthly payments are, we don't have to use the PMT formula. And the other thing that they do not tell us is what the original principal was, right? Like, where did they start? When they took the loan out initially, for this home mortgage. So they're giving you the monthly payments here. They're telling you you have a 6% APR. They want to know what will be the balance in 5 years' time. So that means you are basically looking at 25 years that are still remaining. So they of course have the monthly payments of $1,000, your rate of interest of 6%. Since you're doing monthly payments, n equals 12, and then time is 25, because we're talking about what would be the balance in 5 years' time. So if you're using the PV formula, then of course you're still looking at R divided by N for the first argument, N times T, and in this case, 25 years, your monthly deposits, and then again, future value would be 0. So basically you can see it gives you a dollar amount of $155,206.86. If you were to use the textbook formula, obviously keeping those same numbers, N equals 12, T equals 25, R is 6%, your deposit of 1,000, and of course you will see basically you've paid the monthly payments for 5 years, you still have 25 years to go. This is what our balance is going to be at the end of the 5 years you've paid and 25 years we have remaining. So this calculation, because it was not halfway, they just did 5 years, you had to figure out how much you were left behind with. In our example, because they did 15 years and this was a 30-year loan, you have paid for 15 years, but you also have 15 years remaining. So that's why this number stayed, 15. But if they had given like 20 and 10, then we would have done the same calculation like they did here. You've paid the loan for 5 years, but you have 25 years remaining, and we would have to make that adjustment. Okay, so basically they are saying these are the 2 steps involved in when you're trying to figure out what your remaining balance is. Calculate your monthly payment on the loan, and then based on how much time you have left, so based on the remaining time, calculate your present value. So those are basically the 2 steps involved in calculating what your remaining balance is going to be. Oh. Am I unfrozen now? Yeah, sorry, I'm not sure what happened over there. So just basically those would be your two steps over here, guys. So remember, this is finding the PMT or your D value. This guy is finding the present value or the principal. So that's basically your two steps in figuring these remaining loans, okay? And then the last part over here, guys, was the credit cards. Now, credit cards, they kind of keep it very simple. And I know we're already at 12:27, but with the credit cards over here, it's basically, they do it in terms of, kind of like the calculations we have done. So if you look at this example over here, they're talking about, I guess that's Bilkis, has a credit card, at 17.99% APR, and it's compounded daily. She uses the card to buy a $900 plane ticket, does not make any payments during the interest-free grace period. The first payment is due 35 days after the grace period has ended. They're talking about following the fine print in the agreement for the credit card, the minimum payment is calculated to be 1% of the outstanding balance after you apply the APR, or $25. So the minimum payment is either going to be 1%, after they've added the interest on, or $25, whichever dollar amount comes to be larger. So they want to know what the outstanding balance would be, what the minimum payment would be. And of course, once you have paid the minimum payment, what would the new balance end up looking like? So in this case, guys, when you are applying your 17.99% APR, you are actually going back to the compound interest formula with compounded daily. So this is the formula they went back to, where your principal, of course, is the $900 plane ticket that she bought. The rate of interest, of course, is your 17.99%. We are making a compounded daily calculation here. So N is 365. And then time in this case is actually going to be just 1 year, because, you don't really keep %9 here, compounded daily. But look at that exponent. It's not really N times T. And the reason for that is they are telling us her first payment is due 35 days after the grace period has ended. So that is where we are trying to figure out what her interest would be. And that's where that 35 is coming from. So this exponent is actually just going to be, those 35 days where the interest is being calculated. And so you can see it's coming out to be $915.66, which is what her balance would be once the APR has applied. Then they told us, oh good Lord, why am I freezing? Am I still frozen? I am not sure why it's doing that. Let me check my internet over here, guys. I thought it looked okay. It's showing me full strength. I'm not sure what's going on. I apologize for that. So that's the only difference you're going to see here, guys, is in that exponent, because instead of doing, N times T, like I said, you're not calculating this for an entire year, just for that billing period, which is going to be that 35 days over there. You can kind of see they are using the future value formula over here. They did the same thing. So 17.99% divided by 365. You're only doing this for 35 days. We're not making any regular payments. So this guy is 0. And then, of course, we started out with $900, as the charge. So now that you know that we owe $915.66, and remember they told us that your minimum payment can either be 1% of the outstanding balance or $25. So if you take 1% of this, this is coming out to be $916. So that means since $25 is larger, our minimum payment is going to be 25. Now, if Bilkis only pays her minimum payment and only makes a payment of $25, then of course from that $915.66, your new balance will come out to be $890.66. So this is a slightly different way that credit cards are calculated because you have to do it on a day-to-day basis and not so much as, you know, how we saw, let's say something in the last section, or, you know, even section 2.2 for that matter, where we talked about compound interest. So over here, they go through all the different examples, functions you have seen for the spreadsheet formula. So you can see all of them are listed over here. They're defining what each of the arguments are. I really like this section over here where they're talking about when to use the formula. So, you know, if you're looking for regular deposits, payments, that's the PMT. In section 2.2, we talked about the effective rate and then different calculations for the interests. And then these are all your textbook formulas over here. So they've made a nice summary of all the different formulas you have looked at in this chapter over here. So that might be something to, you know, keep handy as you guys are looking through these examples and working with them. So all of your spreadsheet formulas are here, and then all of your textbook formulas are right over here. And then this last part again is just talking about recognizing when to use which formula in this case. So what I would like you guys to do is, you know, obviously go ahead, look through any of these examples. You have all of your homework sections available in My Open Math. So hopefully you guys, and like I said, I know I have messages from you and I will get to answering those right after we end class. So all of your homework sections are available over here, guys. Work through those. Let me know if you have any questions. I'm going to hang out here on Zoom because I know some of you said you were needing my help. I'll answer those questions. And then for the rest of you, I will see you on Wednesday and we'll be taking our chapter 2 exam. And like we did last time, we're only going to do exam that day. So as soon as you're done with the exam on Zoom, I'll give you your passwords once you come into class. You are allowed to have your notes, some kind of cheat sheet if you like. You know, you can use the spreadsheets. So I sent you the link for the spreadsheet in the Zoom chat. I would say save those, and then you should be able to use your own, you know, formulas and stuff in there. But I think that would be a good practice to kind of look at that. So save that link. And then let me know if you have any questions regarding the exam, guys. But our format is going to be pretty much similar to last time, okay? And once you're done with the exam, you'll be welcome to leave the Zoom session, okay? All right, guys, this is where we'll stop. Stay back and answer, and I'll answer any questions, and then I'll see you on Wednesday. Bye, guys. Be careful. Michael, go ahead.
How long will the